Bismillahirrahmanirrahim. Assalamualaikum and hi everyone. We are from Layer Revenants. We present our final project for subject KNP 3492 Engineering Design 2. So before we start, I would like to invite you to join us by scanning this QR code. For more and complete information about our project, you will be directly connected to our brochure template and hope you will enjoy this presentation. So our Lion Revenants company is led by our project leader, Mr. Tian An San, with other command member, Mr. Bung Kiat as executive manager, Mr. Darren Ling, our design manager, Nurul Amira as technical manager, and me myself, Nur Izzati Akmal as operational manager. So with the company motto Design in Evolution, our vision and mission is to be the best and apply the knowledge of engineering and making environmentally friendly product. In this presentation, we will present three parts in engineering design process, which are conceptual design, embodiment design, and detail design. Briefly, this project takes 4 months from 1st March until July 2020 to be complete, from problem definition until preparation of report and presentation. Next, from the problem given, we can sort out the important key in this project is we need to fabricate a construction machine that can be worked at a rural area. The machine need to be able to work at high and moving object. However, the highlighted problem is to reduce the common hazard in construction area. Before we focus on the design, we collect all the information externally and internally. For external information, we do an interview with Mr. Michael as a need for our customer requirement. And for better understanding about the rural area, we also do an interview with Ms. Fazlin Abdul Hazizi from Civil Engineering Department to know more about the soil condition that will affect our product later on. Other than that, we also do a research and benchmark from other existing products in the market. From all the information gathering, we take note the customer requirement and produce house of quality HOQ to help us focus on important rank to start our design. As you can see in this HOQ table, the first rank order will be the dimension and lifting capacity, followed by the safety, weight, weather resistant, vehicle safety, power capacity, and material toughness. We also do a benchmarking with 3 others existing design in market. The details of this part will be explained at the end of the presentation. That's all from me. I'll pass to the next presenter, Mr. Darren Lee.
Thank you, Jati. Next, we will move to the trees diagram. The scissor lift basement support the working platform and the hydraulic control system, whereas the top working platform holds the brakes. The hydraulic control system is controlled by the human worker and it operates the motor to control the hydraulic pump to move the hydraulic cylinder. The hydraulic cylinder will push the scissor support to lift the working platform. Next, we will move to the cause and effect diagram. In this diagram, there are several factors that cause the scissor lift to become unstable, which is the improper design, sharp scissor link angle, environmental factor, overload, and operating at height. Next, we will move to the product architecture. In our project, there are 4 modules, which is the power generator module, lifting module, moving module, and holder module. Next, we will move to the truck view. This is the orthogonal view of the scissor lift when it is installed on a truck. Next, we will move to the connector. This is the orthogonal view of a connector with detailed parameters. The connector is located between the scissor lift and the truck. Next, we will move to the scissor lift. This is the orthogonal view of the scissor lift with detailed parameters. Next, we will move to the top platform. This is the orthogonal view of the top platform with detailed parameters. Then, this is the diagram that shows the truck before and after lifting. Next, I will pass the presentation to Jack. Thank you.
Thank you, Darren. Next, I will talk about the parametric design. The total load of the scissor lift includes of bricks or the load, roller platform, safety rail, link, and hydraulic cylinder is equal to 1,610 kg or 15794.1 Newton. Next, for the connector pin, hinge joint, and support reaction, we will only consider the most bottom links as we assume that most bottom link is easiest to occur deformation and failure. Following are the calculation for the hinge point, connector pin, and separation. As you can see, the minimum force to be exerted by the hydraulic pump is equal to 22556.31 Newton. So, by using Pascal law, the minimum pressure needed to lift the load is equal to 3.54 megapascal. Following is the link analysis. Mount steel is chosen, and by using the finite element analysis method or the aid of ANSYS software, we found that the maximum principal stress equal to 0.615 megapascal, minimum principal stress is equal to 435 pascal, and the deformation of the link which occur at the edge of the link is equal to 9.7 times 10 to the power of negative 8 meter. Following are the link analysis performed by ANSYS. Thank you. Next, I will pass to Anson.
Thank you to my friend Bunket. Now I will present about bolt and nut analysis. We use two types of bolt and nut, which are M20 x 200 mm to fix the end of the hydraulic cylinder and M20 x 300 mm to hold the scissor lift to the truck. M20 x 200 mm is made of grade 8.8 bright zinc plated. It is cheap in price, and then zinc plating is known for its ability to prevent moss corrosion. M20 x 300 mm is made of A2 stainless steel. A2 stainless steel made the bolt and nut are invulnerable to corrosion. Zinc coating can have the same purpose, but zinc coating is vulnerable to scratching. Sharp material in construction site will make plating down. Thus, stainless steel is more favorable. Material selection. Material selection is important for designing a product, as different parts of the mechanism take different load and stress because they carry out different function. Our main concern is scissor support, hydraulic cylinder, working platform, and base support frame. To ensure our product function at most optimum performance, proper material selection need to be taken into consideration. In manufacturing industry, cost is everything. Therefore, mill steel become our choice because it is the cheapest among three material. Second, mill steel has the medium ultimate tensile strength and has the highest yield strength. Thus, we choose mill steel as it has excellent physical property such as strength, toughness, ductility, and hardness of our main concern above. Product design specification. Basically, from what you can see, our product use hydraulic system and able to lift brick to 4 meter high with great safety feature such as safety rail and roller platform. Its weight is 110 kg and able to lift 1000 kg of brick. This is our product, attachable scissor lift. Next, I will pass to my friend Mira.
To Tian and Sen. Now I'm going to explain about the bills of materials. Based on the slide, it shows how many quantity that we need for a part, and for each part, we decided the materials and the dimension. Next, for the comparison, we compare our product to 3 different companies with different vehicle. First company that we compare to is Howlett's company that produce telehandler. Based on the slide, telehandler lifting capacity is 3,500 kg and the working height is 10 meter. And the power generation that they use is diesel engine, and the lifting system is hydrostatic. And for our product, iron never next truck, our lifting capacity is 1,000 kg and our working height is 4 meter and our lifting system is scissor lift. Next is Sennebergen company, which is a company that produces crawler crane. Crawler crane power generation is diesel engine and the lifting capacity is 32,658.7 kg. The working height is 38 meter and the lifting system is hydraulic. And lastly, a company that produces fixed crane, which is Seni. Fixed crane power generation is electric and the lifting capacity is 6,350.29 kg and the working height is 46 meter. The lifting system is gear and motor and it is ideal for lifting. Finally, the conclusion for this project are that we can improve several skills such as CAD skills and NSYS. We finally can design a truck that achieves the requirement, which are can lift to high place, and the safety is our main factor. We decided to use scissor lift as our product because it is easy to use. Then the routine maintenance is not required. And that's all from us, Group 8. Thank you.